We're here again with Can We Do That? Some more, our opportunity to try some more maths based on what we've looked at in the most recent Can We Do That video. So, today's topic, combining two graphs into one equation. If you have no idea what I'm talking about when I'm saying that, do have a look at that Can We Do That video that this is paired with. Anyway, it's worth mentioning that this video covers things you're not meant to know for the A-level, so don't worry about it. This is just for fun and therefore nothing to stress about, even if you don't understand what we're doing today. But hopefully I do enough explanation so you do understand what's going on, either in this video or the actual proper Can We Do That video. Anyway, here are the questions we're trying in today's video. So at this point, you might want to pause the video, have a go at these questions yourself, and then come back and watch what the answers are if you want to do that. So, yes, here is our first question. We got to combine these two separate graphs into just one graph with one equation. How do you do that? Well, we said in the Can We Do That video, all it's a case of doing is rearranging each of them so they're equal to 0. So that first one would become that, the second one would become this, and then those two things act as factors of a bigger equation. So therefore we're going to have this. And there we go. Amazing. It's the great mathematical magical trick, this stuff, really. Because we've done it. One graph, one equation, but it's secretly representing two graphs at once. I didn't say what format I wanted you to leave the answer, which was a bit silly of me in the question. I should have thought that out. So therefore some of you might have multiplied the brackets out, but you didn't need to, because the question didn't ask you to, but also didn't tell you not to. So, in case you want to check whether you did that correctly, in case you did do that, this is what you would get if you did multiply the brackets. Gathering the like terms with the y's. And then the end, 12x to the power of 7. Be very easy to make a silly mistake with that bit on the end. Index laws, watch out for that. But there you go. That's the first equation done. On to a second pair of equations that we want to combine. And interestingly, with this equation, it's different to some of the things we actually looked at in the Can We Do That video, because in the Can We Do That video, we only looked at graphs that were of the form y equals. So therefore, that's interesting, because you might be wondering what to do, except actually you don't need to, because it's the same method. No matter what the graph is, rearrange it to make it equal to 0, because it will still then act as a factor when multiplied by other graphs. So I know it's a scary y squared graph because it's a circle, except it's not really that scary. But all you got to do then to get the mega graph, that's not the actual official terminology, by the way. I do that a lot. I say words that aren't really proper maths terminology, and I pass them off as if they are. Anyway, there we go. That is the graph, Now, that'll be fine. Some of you, for some reason, might have felt you had a bit of time to spare and decide to multiply those brackets out. I don't know why you do that, because it's horrible, but if you did, I'm going to do the same as you, in solidarity with the pain you went through if you did do that. So let's see what you get if you were to do that. So, using a trusty grid method, the classic, we end up with, well, I'm not doing it yet, I'm still writing out the grid. Blimey, that's when you know it's going to take long, when even just writing out the grid is effort. Anyway, we have x squared y minus x to the power of 4, x squared y cubed minus x squared y squared, y squared, y, actually it's a minus y. Oh, I was almost caught out by that. Positive x squared, and then a minus 1. So the overall equation is this: x squared y minus x to the 4 plus x squared. You might notice, by the way, nothing simplifying, which therefore means it really was a complete waste of time to multiply the brackets. But I did it anyway. There you go. So that is the equation that represents a circle and a quadratic of the form y equals x squared minus 1, all together in one big graph. Now, I must admit, I did do this for another reason, and it's just to illustrate that the amazing thing about this is if you looked at an equation like this, not that you ever would be given an equation that anything like this in Maths A-level or further Maths A-level, But if you did come across, for some bizarre reason, an equation that looked like this, you would never in a million years guess that this was something you would actually be able to graph. And you would know what it looked like. But there we go, that's the amazing thing about algebra. Sometimes makes some things look way more scary than they actually are. Anyway, now what we're doing is the same idea, but in reverse. So, let's do it. Some of you might be able to look at this easy one and just instantly be able to factorize it. Because, by the way, in case you're wondering, yes, it does just factorize to y plus 2x, y plus x. Nice. But some of you, and then you can get the graphs from that, some of you might prefer to use the quadratic formula to do this because it still works out very nicely if you do that. Our minus b, so our b term was 3x, so it's minus 3x, plus or minus the square root of b squared minus 4 times a, which is 1, times by c, which is 2x squared, square rooted, all over 2 times a, which would be 2. So then we just got to do a bunch of simplifying. So we end up with minus 3x plus or minus 9x squared minus 8x squared. And what do you know? You can probably already see that it's working out really nicely. But that's not surprising because it factorizes nicely, then the quadratic formula will work out nicely. That's the rule of how this stuff goes. So, therefore, we end up with two graphs. We either end up with minus 3x minus x all over 2, which is, of course, minus 4x over 2, which is, of course, minus 2x. So y equals minus 2x is one of the graphs. Or you alternatively might have minus 3x plus x all over 2, which is minus 2x over 2, which is y equals minus x is the other graph we have. Nice. So there we go. Those are the two separate graphs represented by that one equation. On to the next question, and it looks so much scarier. Some of you might be able to factorize this one. Well done if you did, but a lot of you probably will definitely prefer to use the quadratic formula on this one. So if you were to do that, again, it is a quadratic. It's a bit weird because it's a quadratic in y, because we've got y squared, a y, and something without y involved at all. So even though there's x's, looks scary, but we can still use the quadratic formula. So that's what we're going to do. So y equals the minus b. Now, as b already has a minus sign in it, doing minus b, we'll just get rid of the minus sign. That's the easier way of doing it. Plus or minus the square root of our b term all squared. Now, again, because the b term is already a negative number, we know a negative thing, I should say. As it's a negative thing squared is guaranteed to be positive. So it's the same as just squaring the positive version of it. So to save me writing it out. Ironically, by saying all that, by the time I'd explained the fact I was doing that, I could have just written it out. Oh well. And then divided by 2a, which is this time 2x. So it's more complicated than last time. Of course, we're going to multiply out the brackets inside the square root. That'll end up with a 16. 4 times 3, which is 12, times by 2 is 24. Lots of x squared. Plus 3x squared all squared, which is 9x to the power 4. And then minus 48x squared. All over 2x. And doing some more simplifying, 4 plus 3x squared plus or minus. Now the interesting thing is the 24x squared and the minus 48x squared combine to make minus 24x squared. And the reason that's interesting is because it now means what we have inside the square root is exactly the same as what we had when we squared out, that's horrible terminology, the 4 plus 3x squared, but with one difference, which is the fact that we've now got a minus sign in front of one of the things, one of the terms that was formed from that. What does that mean? Well, it means that just one of either 4 or 3x squared has to have a minus sign in front of it now inside the brackets. It doesn't matter which one you choose, because the magical thing is because of the plus minus in front of the square root, both combinations will be accounted for either way. So it doesn't matter. I'm going to therefore do 4 minus 3x squared, but you could do 3x squared minus 4, and it would still be equally valid. Two different ways you can factorize the things that we have there. Still divided by 2x. So therefore we have 4 plus 3x squared plus or minus 4 minus 3x squared. All over 2x. So we've got two options. Either we have 4 plus 3x squared plus 4 minus 3x squared, all divided by 2x. If you simplify that, that will get you 8 over 2x, which therefore means y is equal to 8 divided by 2 is 4 over x, or 4x to the power minus 1. Amazing. So that's one of our two graphs. The other graph is going to be 4 plus 3x squared minus 4 minus 3x squared, all over 2x, which of course you could do a bit of rewriting to make sure you've multiplied out the brackets correctly. Minus 4 plus 3x squared over 2x, which is equal to 6x squared over 2x. And therefore that leads to the other graph of y equals 3x. There you go. Those are our two graphs there, and we've done all the questions. Isn't that amazing? Genuinely, I think this is pretty cool. The quadratic formula it looks like it shouldn't be allowed to be applied to situations like this, but it can be. And actually, in fact, as I said in the Can We Do That video, if you're interested in exploring this idea of applying the quadratic formula to things that it shouldn't be applied to, then let me know in the comments, because I'd love to make a video on that as well at some point, because it's pretty cool. Anyway, that will do us for today. In case you're interested, have a look at checking out some of my other videos in my other series, such as the Can We Do That series at large. There's loads of interesting ideas in that, things to explore, and also the Prove It series, where we're trying to prove everything in the Maths A level and further Maths A level. It'll take me a while, but we'll get it done eventually.